Distribution board. In this lecture, we are going to talk about DB, definition of DB, description of DB, components of DB, load schedule, and show some DBs. So let's get started. DB or distribution board is an electric panel which is used to distribute current to electric or electronic devices such as lights, motors, TVs, and ACs. Of course, you've become familiar with this wiring. Yeah, at that moment we used to say connect the live wire to the main supply, connect the neutral wire to the main supply, and even the earth wire. Actually, the main supply refers to a DB. Never mind, I will discuss the components of DB in the coming slides. DB is smaller than MSB, but shares same features, which is distributing electrical. However, the main difference between DB and MSB is the value of the load and the size of the panel, so that MSB is designed for high loads, while DB is designed for lower loads than MSB. Usually, the maximum incomer breaker for DB is 100 ampere or 125 ampere. By the way, the size of the panel in general looks like 40 times 80 centimeter. I mean 40 by 80 centimeter width and height. So yeah, we conclude that a dB is a small scale of an MSB. The main components. Okay, number one, the incomer breaker, which is called MCB, miniature circuit breaker, and it is a three-phase breaker. Number two, the outgoing MCBs, which can be used as single-phase or three-phase breakers. Number three, ELCB, or earth leakage circuit breaker, and this breaker is used for safety. So if there is any leakage current, it will trip off. The bus bar, number four, the bus bar, as you know, it's used to pass the current through it in order to feed the outgoing MCBs. Pay attention that it could be 2 or 3 bus bars in 1 dB. Well, these are the main components of the dB. Please note that the outgoing MCBs could be single-phase circuit breakers, or three-phase circuit breaker. And we call each 3 single-phase circuit breaker way, which means the way consists of 3 phases: red phase, yellow phase, and blue phase. Therefore, a 3-phase circuit breaker is called way, also because it consists of 3 phases. For example, if we have a dB consists of 6-way, it means we might have 18 single-phase circuit breakers, because each way consists of 3 phases. Let's make a quick review for the main components in the dB. Okay, first we have the incomer breaker. So an MCCB feeds this incomer breaker. The incomer breaker feeds the ELCB. Then the ELCB feeds the bus bar. Finally, the bus bar feeds the outgoing MCBs. Yeah, the outgoing MCBs feed electric devices. On the other hand, these are neutral plates and earthing joints. Of course, you have to connect neutral wires and earth wires there. We can simplify the procedures by these blocks. I think it's clear. Let's move. This is a real dB. I did this one, by the way. Okay, let's analyze this dB together. First, we have the incomer breaker. Meanwhile, there are 2 ELCBs, and the incomer breaker feeds both ELCBs. Okay, please pay attention. Because we have 2 ELCBs, we must have 2 bus bars, this one and this one, which means each ELCB feeds 1 bus bar. Finally, each bus bar feeds its outgoing MCBs. I think it's so clear, so simple. Let's see another dB. Well, we have this dB now. Anyway, this dB is designed by a different person. I'm not the one. But yeah, we can analyze it. Why not? So let's do it together. We have the incomer breaker, which feeds two ALCBs. Then the two ELCBs feed the bus bars. Of course, each one feeds one bus bar. Finally, the bus bars feed the MCBs. You can see the neutral plates. There are two, one for each bus bar. While here is the earth plate or earth joint. Simply, it's used for earth wires. What else? Yeah, look here to the outgoing MCBs. It's clearly that they are divided in three different colors, which refer to three-phase wire: red, yellow, and blue. Since the incomer breaker is three-phase, so the three phases voltages, three phases voltages must be divided among the MCBs. As you can see, we start with red phase, yellow phase, blue phase. Again, red phase, yellow phase, blue phase. Again, red phase, yellow phase, blue phase, and so on. Never mind, you will understand it more later. But before we leave this slide, let me ask you a question. How many way in this dB? I will give you 10 seconds. Okay, we said before a three-phase circuit breaker or three numbers of single-phase circuit breaker is called way. I will simplify it more. Just count red, yellow, blue as one way. So come on, let's count it together. We start here. Red, yellow, blue, way 1. Red, yellow, blue, way 2. Red, yellow, blue, way 3. Red, yellow, blue, way 4. Red, yellow, blue, way 5. Red, yellow, blue, way 6. That's it. Load schedule. The load schedule is the ID card for the DB. It gives details for the components inside the DB, so that in the load schedule you have to consider the following: the number of way and the value for each circuit breaker, the quantity of bus bar, the quantity of ELCB and its value, the loads for each equipment, the thickness of wires, and the address for each circuit breaker. Don't worry, we will describe it later, the load schedule. Okay, let's move. Different design can be made for DBs. We can design it with single, double, or triple bus bar. Also, we can design it with two-way, four-way, six-way, eight-way, and so on. One more thing, inside the DB, the MCBs might be single-phase or three-phase. I mean, you may find inside a DB single-phase MCBs and three-phase MCBs at the same time, which is normal without any problem. Well, this was everything for this lecture. I will see you in the next lecture. Good luck.